Welcome to Mindful Moments. Nourish your mind on the go. This audio uses AI narration to present our original book analysis. Today, we're taking a deep dive into Neil deGrasse Tyson's Astrophysics for People in a Hurry. It's kind of like a backstage pass to the universe's greatest hits, even if you're in a hurry. Imagine grasping the Big Bang, dark matter, and even the possibility of alien life, all in a quick but insightful journey. We're about to uncover some seriously cool facts from this book that'll have you dropping cosmic knowledge at your next gathering.
It really is remarkable how Tyson manages to break down these incredibly complex ideas into something so easy to understand. He just has this way of making you feel like you're having a casual conversation with a brilliant astrophysicist, maybe over a cup of coffee or something.
You're right. He really does. So
Yeah.
To kick things off, let's rewind all the way back. And I mean way, way back to the Big Bang. This wasn't just any bang.
Right.
This was the ultimate cosmic firecracker that set the universe in motion.
Exactly. Picture everything, and I mean everything, squeezed into a point so tiny, so incredibly dense, it's almost impossible to even imagine. And then, boom, in a fraction of a second, this point explodes outward, expanding and cooling at an unimaginable rate.
Okay, so this rapid expansion and cooling, was that kind of like a cosmic recipe where things started to settle and combine as the temperature dropped?
That's a great way to put it. As the universe cooled, that initial burst of pure energy began to condense into the first particles. Imagine a cosmic dance floor where particles are constantly colliding, some annihilating each other in a flash of energy, and others forming new, heavier particles.
Oh, it's chaos in this early universe.
Yeah.
But organized chaos.
Yeah.
Kind of like a cosmic ballet with matter and antimatter as the main dancers.
Exactly. And here's where the story gets even more interesting. In this dance of creation and destruction, there was a tiny imbalance. For every billion antimatter particles, there were 1,000,000,001 matter particles.
Hold on. Antimatter, that's not just science fiction?
Ugh, it's very real. Think of it as matter's mirror image. And when matter and antimatter meet, they annihilate each other, converting their mass back into pure energy. Einstein's famous Iman-Say-Lastic in action.
Okay, so a slight surplus of matter after all that annihilation. Is that why we exist?
Okay.
Because of this cosmic leftover?
Precisely. That tiny surplus is the reason we have a universe filled with stars, planets, das. As things continue to cool, those surviving particles, quarks, started to clump together, forming heavier particles like protons and neutrons.
So we're talking about the building blocks of atoms here.
Yeah.
Right,
Yeah.
the stuff that makes up everything we see and touch.
You got it. As the universe continued to cool, these protons and neutrons began to fuse, forming the first atomic nuclei, predominantly hydrogen and helium. This all happened in the first few minutes of the universe's existence. Talk about a busy morning.
That is seriously mind-boggling. So we've got these atomic nuclei swirling around. What happens next?
Fast forward about 380,000 years, and the universe is cooled enough for electrons to join the party. They get captured by those nuclei, forming complete atoms. It's like the universe finally took a deep breath and relaxed. Before this, it was a dense, hot fog of particles, opaque to light. But once those atoms formed, light could finally travel freely.
Hang on. Are you saying that light from that moment, from those very first atoms, is still out there?
You bet. It's called the cosmic microwave background radiation, or CMB for short. It's like the faint afterglow of the Big Bang, a whisper of the universe's fiery birth that permeates all of space.
Wow. So by studying the CMB, we're essentially looking back in time, getting a glimpse of the universe as a baby.
Exactly. And it's not just a pretty picture. The CMB has these tiny temperature variations, like wrinkles in the fabric of space-time. Those wrinkles tell us about the early universe's structure and how things were clumped together, eventually giving rise to galaxies and clusters of galaxies.
Okay, so from an infinitesimal point to a universe brimming with galaxies in just a few 100,000 years, that's quite a growth spurt.
That's the Big Bang for you. Now, ready to delve into the mysteries of dark matter and dark energy? They make up a whopping 95% of the universe.
Let's do it. Those are the cosmic enigmas I've always wanted to understand better.
Buckle up, because things are about to get really interesting. Imagine looking at a beautifully lit cityscape at night, but what you're seeing, all those sparkling lights, only represent a tiny fraction of what's actually there.
You're saying there's a whole lot more to the universe than meets the eye. That's both exciting and a little spooky.
Exactly. We call this hidden stuff dark matter and dark energy. We can't see them directly, but we can see their effects, their gravitational fingerprints on the visible universe.
It's kind of like seeing the indentation on a trampoline. even if you didn't see what bounced on it.
Perfect analogy. Astronomers noticed that galaxies were spinning way faster than they should be based on the visible matter they contain. It's like watching a merry-go-round whirling at dizzying speeds with only a few kids on board. Something invisible has to be providing that extra gravitational oomph.
And that's where dark matter comes in. It's like the invisible scaffolding holding those speedy galaxies together.
Precisely. And we see the same gravitational weirdness on a larger scale with clusters of galaxies. Dark matter is shaping the large-scale structure of the universe, acting like a cosmic web that draws everything together.
Okay, so dark matter is the invisible glue. But what about dark energy? It sounds a bit more ominous.
Think of it as a repulsive force, kind of like anti-gravity. It's causing the expansion of the universe to speed up, like a cosmic accelerator pedal that's been pushed to the floor.
Wait, so the universe isn't just expanding, it's expanding faster and faster? That's mind-boggling.
It is. One of the leading ideas is that it's connected to the energy of empty space itself. Quantum physics suggests that even the vacuum of space is buzzing with virtual particles popping in and out of existence. This could create an outward pressure driving the acceleration we observe.
So the emptiness of space isn't actually empty. It's like a seething cauldron of quantum activity.
That seems to be the case. It's one of the biggest mysteries in astrophysics.
I'm starting to see why this book is called Astrophysics for People in a Hurry. We've covered the Big Bang, the formation of the first atoms, dark matter, and dark energy, all in a matter of minutes.
We've only just scratched the surface. There's so much more to explore, from the fascinating lives of stars to the possibility of life beyond Earth.
This is definitely making me thirsty for more cosmic knowledge. I can't wait to see where this deep dive takes us next. So before the break, we were on this whirlwind tour of the universe's dark side. You mentioned galaxies being like these cosmic islands, and it's hard to imagine anything grander than those swirling galaxies we see in pictures. But how much do we actually know about them?
Galaxies are like the metropolises of the universe, these vast collections of stars, gas, dust, planets, and weight, of course, a generous helping of that mysterious dark matter. And just like cities here on Earth, they come in different shapes and sizes, each with its own unique story to tell.
It's just incredible to think about those stunning spiral galaxies, like our own Milky Way, with those arms swirling with starbirth. What creates those intricate patterns?
Those spiral arms are actually kind of like cosmic traffic jams. As stars and gas clouds orbit the galactic center, they get bunched up in these spiral density waves. Imagine cars slowing down as they approach a construction zone on a highway. It's a similar concept.
Oh, so those traffic jams are where stars are born. What about those other galaxies that look more like smooth, rounded blobs?
Those are elliptical galaxies. Think of them as the older, more settled cities of the cosmos. They've used up most of their gas and dust, and star formation has slowed down. They're still beautiful, but in a more serene, stately kind of way.
Like Tyson mentions dwarf galaxies, too. These smaller, less glamorous cousins of the spirals and ellipticals. What role do they play in this whole cosmic drama?
Dwarf galaxies are like the villages and towns scattered across the vast cosmic landscape. They're much smaller and fainter, but incredibly important. They were among the first galaxies to form, and they've been interacting and merging to build larger galaxies over billions of years.
I remember Tyson talking about galactic cannibalism. Is that what happens when these smaller galaxies get too close to their larger neighbors?
Exactly. It's a cosmic tug of war. The Milky Way, for example, has been pulling in and absorbing smaller dwarf galaxies throughout its history. In fact, some of the stars we see in our night sky might have originally come from these galactic mergers.
So our galaxy's a bit of a stellar kleptomaniac.
Yeah.
Snatching stars from its smaller neighbors. What happens to those stars that aren't caught up in these galactic mergers? Are there any stellar nomads out there?
Absolutely. There are stars that have been ejected from their galaxies, perhaps by the gravitational slingshot of a supermassive black hole, or maybe a close encounter with another galaxy, and they wander through intergalactic space alone and adrift. We call them rogue stars, or sometimes interstellar stars.
Those rogue stars.
Yeah.
It's like they've been cast out of their cosmic homes. But their journeys must offer a unique perspective on the universe.
Indeed. Now, imagine being an astronomer trying to understand these distant galaxies and stars. How do we decipher their stories? Well, one of our most powerful tools is something called spectroscopy.
Spectroscopy. That rings a bell. But how does that work again?
Think of it as a cosmic prism. When we pass starlight through a spectroscope, it splits the light into its different colors, like a rainbow. But these rainbows are more than just pretty colors. They contain hidden messages.
Messages? What kind of messages?
Each element, when heated, emits or absorbs light at very specific wavelengths, creating a unique spectral fingerprint. By analyzing these fingerprints in starlight, we can determine the chemical composition of distant stars and galaxies.
So, it's like a cosmic barcode that tells us what those stars are made of.
Precisely. Spectroscopy can also tell us things like a star's temperature, its motion towards or away from us, as even whether it has planets orbiting around it.
That's amazing. It's like we're having a conversation with the universe, reading its secrets through the language of light.
It really is. And speaking of secrets, one of the most profound insights we gain from astrophysics is the realization that the laws of physics are universal. The same forces and principles that govern the behavior of matter and energy here on Earth also apply throughout the cosmos.
That's a pretty big deal, right? It means that everything in the universe is connected, playing by the same rules. It makes me think of that phrase, "we are stardust." Is there any truth to that?
Absolutely. It's not just poetic, it's scientific fact. Stars are like giant cosmic factories where heavier elements are forged from simpler ones, a process called stellar nucleosynthesis.
So those elements that make up our bodies,
Yeah.
the carbon in our DNA, the iron in our blood, they all originated in the hearts of stars.
Exactly. The story begins with hydrogen, the simplest and most abundant element in the universe. In the intense heat and pressure of a star's core, hydrogen atoms fuse to form helium, releasing tremendous amounts of energy in the process. That's what makes stars shine.
And this fusion process continues, creating heavier and heavier elements.
But precisely. Helium fuses to form carbon. Carbon fuses to form oxygen, and so on, building up the elements of the periodic table.
So stars are like cosmic alchemists,
Yeah.
transforming one element into another. But how do these heavier elements get out there to form planets and eventually?
When massive stars reach the end of their lives, they don't go quietly. They explode in spectacular supernovas, scattering their newly forged elements into space. These stellar explosions seed the next generation of stars and planetary systems with the ingredients for life.
Wow. It's amazing to think that the calcium in our bones and the iron in our blood were once part of these fiery, explosive events.
We are literally made of stardust, the remnants of long-dead stars. It's a pretty profound thought, isn't it?
It is. It gives a whole new meaning to the idea that we are connected to the cosmos now. With all these billions upon billions of stars out there, it seems almost impossible that we're alone in the universe. Does Tyson address the possibility of life beyond Earth?
He does, and he makes a very compelling case that, given the sheer number of stars and planets out there, it would be statistically improbable if life were unique to Earth.
Finding evidence of that life is another matter, though. I mean, where do we even begin to look?
One promising avenue is the search for exoplanets, planets that orbit stars other than our sun. In recent years, astronomers have discovered thousands of exoplanets, and some of them are located in the so-called habitable zone, where temperatures are just right for liquid water to exist on the surface.
Liquid water. That's considered the key ingredient for life as we know it.
Yeah.
Right.
Exactly. And as we develop more sophisticated telescopes and techniques, we'll be able to study the atmospheres of these exoplanets, looking for chemical signatures that might hint at the presence of life.
So we might actually find evidence of life on another planet soon, even if it's just microbial life.
It's certainly a possibility. And if we did, it would be one of the most profound discoveries in human history, transforming our understanding of our place in the universe.
I can only imagine. The thought of finding alien life is both exhilarating and a bit daunting. It makes you wonder what forms that life might take, and how their evolution might have been shaped by their unique planetary environments.
It does. And it reminds us that there's still so much we don't know about the universe and its possibilities.
I remember Tyson discussing a concept called panspermia, the idea that life could have originated elsewhere and then been transported to Earth. Could we all be descendants of Martian microbes?
That's a fascinating idea. Panspermia suggests that life could be much more widespread than we think, hitching rides on comets and asteroids, and spreading from one planetary system to another.
That's kind of a wild thought. So
Yeah.
the universe might be teeming with life,
Yeah.
and we're just beginning to scratch the surface of this cosmic tapestry. It makes you wonder what other mind-blowing discoveries are out there waiting to be made.
That's the beauty of science. It's a journey of endless exploration and discovery.
Tyson also emphasizes the importance of embracing the cosmic perspective. What does that mean to you?
To me, the cosmic perspective is about recognizing our place in the grand scheme of things. It's about understanding that we are part of this vast, awe-inspiring universe, and that our planet is just one tiny speck in the cosmic ocean.
It's a perspective that can both humble us and inspire us.
Yeah. Absolutely. It can make our everyday problems seem smaller, while at the same time, it fills us with a sense of wonder and curiosity about the world around us.
It encourages us to look beyond ourselves, to see the interconnectedness of everything, and to really appreciate the beauty and fragility of life on Earth.
And it reminds us that we are all in this together, sharing this incredible journey through space and time.
Well said. I think that's a great place to pause for now. We've covered a lot of ground, but there's still more to explore in our deep dive into astrophysics for people in a hurry.
Welcome back to our deep dive into Neil deGrasse Tyson's Astrophysics for People in a Hurry.
You know, one thing that really struck me about this book is how Tyson doesn't just throw facts at you. He tells a story, this cosmic narrative that spans billions of years and really makes you feel connected to everything around you. It's like he's taking us on this incredible guided tour of the universe, pointing out all the mind-blowing sights along the way.
He really does. He's a master at weaving together science, history, and philosophy. He wants you to not only understand the universe, but to feel it, to experience that sense of awe and wonder.
Absolutely. And he's so good at highlighting those aha moments in science, those breakthroughs that completely shifted our understanding of the cosmos. Like, remember when we used to think that Earth was the center of everything, that everything revolved around us? Now that idea seems almost charmingly naive.
It really does. The geocentric model of the universe, with Earth at the center, was the accepted truth for centuries. And then Copernicus came along and proposed a heliocentric model, putting the sun at the center. It's a radical shift in perspective, and it definitely wasn't embraced right away.
That's so true. It's a good reminder that science is a process of constantly refining our understanding. We have to be open to new ideas, even if they challenge our most deeply held beliefs.
Exactly. And Tyson encourages us to always maintain that sense of curiosity, that thirst for knowledge, because even now, we're still just scratching the surface of what we understand about the cosmos. Dark matter and dark energy, for instance, which together make up the vast majority of the universe's mass and energy, are still huge mysteries. We see their effects, but their true nature remains elusive.
It is humbling to realize how much we still don't know. It makes you wonder what other incredible discoveries are out there waiting to be made.
It does, but that's also what makes science so exciting. There's always something new to explore, always another question to ask. And Tyson makes a really strong case for why scientific literacy is so crucial, not just for scientists, but for everyone.
I totally agree. In a world that's just overflowing with information, it's more important than ever to be able to think critically, evaluate evidence, and separate fact from fiction.
It is. Scientific literacy gives us the tools to do just that. It helps us make informed decisions, understand the world around us, and really appreciate the power of the scientific method.
Right. And Tyson does a fantastic job of making science accessible to everyone. He doesn't talk down to you, but he uses clear language, relatable examples, and even humor to make these complex ideas easy to grasp.
He really does. One of my favorite quotes from the book is, "If you're not scientifically literate, you're disenfranchising yourself in the democratic process." It really highlights the importance of science in shaping public policy and making informed decisions as a society.
Couldn't agree more. We need to be able to engage in these thoughtful discussions about issues that affect us all, from climate change to space exploration to the ethical implications of new technologies.
And speaking of the bigger picture, Tyson's book really drives home the importance of embracing the cosmic perspective.
What does that mean to you?
Well, to me, the cosmic perspective is a way of looking at the world, a way of understanding our place in the grand scheme of things. It's about recognizing that we're a part of something much larger than ourselves, that our planet is just one tiny speck in this vast cosmic ocean.
It's a perspective that can be both humbling and inspiring at the same time.
Absolutely. It can make our everyday problems seem smaller, while simultaneously filling us with a sense of awe and wonder about the universe and our place within it.
It reminds us that we're all connected, not just to each other, but to all of creation, past, present, and future. And it encourages us to be more compassionate, more curious, and more open to new ideas.
Beautifully said. Astrophysics for People in a Hurry is a must-read for anyone who wants to expand their horizons, challenge their assumptions, and really gain a deeper appreciation for the universe and our place within it.
I couldn't agree more. If you're as fascinated by the cosmos as we are, then you'll definitely want to check out this book. You can find a link to purchase it in the show notes. And hey, while you're at it, don't forget to subscribe to Mindful Moments for more mind-expanding deep dives into the world of ideas. Until next time, keep looking up.